Hello, welcome to our next chapter. You will notice some similarities about this chapter from last chapter. For example, we are going to start by graphing equations. So that's something we've briefly covered in the past, and I'm going to remind you of how that works. But before we do that, we're going to talk mainly about a new topic that you probably never had called systems. So in your title, 6-1, solving systems, we say, of equations by graphing. So we're going to do a new idea and we're going to figure out the answer to this new idea by using an old idea, which is graphing. So as we jump in, we want to get a rough idea of what we're dealing with. Systems, and this is a very important slide, so make sure that you get notes, hit the pause button, like I said, when you need to. Systems have three possible answers. You can have one answer, you can have no answers, or you actually can have an infinite amount of answers. So the possibilities, this is it. This is all you got. You got one answer, no answers, or an infinite amount of answers. So I'm not going to stay on this slide long to keep the video short, but I want to say, once again, pause the video, make a quick sketch. You do not have to be too accurate on this graph, guys. You don't have to show me all the numbers perfectly. Just simply the red and the blue line are two graphs. Just make sure that they cross and you put like kind of a big dot there, because that dot we're going to discover is very important. On the next three slides, I'm going to talk about each situation. So we're going to talk about one solution. We'll move on to the no solution, and then we'll move on to the infinite solution. So let's begin with one solution. Once again, very important slide. Do your best to copy this down. I'm going to make sure I give you a long time to copy these notes because they're very important. The solution to a system is where the graphs meet. That's very important. So you're going to have essentially two lines. Now, this is where the two lines are coming from. Like, where did they get these lines? Right here. This is technically the question. So what's in the box here is the actual question. And then you're going to graph. You're going to graph both of them. And you're simply going to see, where do the lines meet? So I have put a big dot here, and I have an ordered pair of 1, 3. That is the location of where the two lines meet. So I made a few things here. It has one solution. That's it. That's the only answer to this thing. That's it. And the solution is the point 1, 3. So that is the answer. There's only one of them, no others, not two, not four, just one answer. So as we move forward then, we can also have no answers. So what would that look like? Now let me show you. This right here is the question once again. This would be your work per se of how you'd find the answer. But the thing is, there is no answer. Why? Because the two lines are parallels. You read this, make sure you get this in notes, all of it. They do not intersect at any point. That means there are no solutions. So if the answer to a system is where the lines meet, if the lines never meet, there is no answer. Pretty makes sense, right? Pretty logical there. And I want to go through, once again, hit that pause button. I'm sure you're going to need more time for this slide, but take good notes on this lesson because, once again, it is a very, very important lesson setting up this chapter. The last situation is that infinite solutions. And this is a little tricky, so I'm going to explain this slide a little bit. Basically, you'll have two equations. So this is a little tough to see, but this says y equals, I'm going to write it over here, 3x plus 2. The other one says 6x minus 2y plus 4 equals 0. So I'll put a box around it like I did on the other ones. That's the actual question. But what's interesting here is, believe it or not, these are the exact same equation here. Doesn't look like it, but they are. If I was to rearrange this equation and get y by itself, I would actually end up with 3x plus 2. Now, I'm not going to take the time on this video to actually get y by itself. But once again, if you want to take the time, if you don't believe me, you can certainly do that. Get y by itself with algebra. You got to move the 4 over, the 6x over, then divide by -2. You will end up with y equals 3x plus 2. So this is a situation where you actually get the exact same line, but they don't look the same sometimes in the question. So that's where it gets tricky. But I want to recap. You can have, I'll go back to this slide. It's a very important slide. One solution, and that's where the lines meet. You could have no solutions because the lines never meet, or the lines are always meeting. So therefore, you will have infinite solutions. All right, let's try our very first system. Here we go. So I actually started this thing off by showing you the answers. This is actually the question. So this will be one of the first type that you'll do. Same, very, very similar style. Move the graph over a little bit, give me some room to work here. And it says to solve the system. Remember, system is 2 or more lines. So here we go. I have to graph this. I'm going to use colors. It helps a lot. That's in y equals mx plus b, slope intercept form. Where do I begin? I always start on the end of the equation. So I'm going to start with that -1, which is my y-intercept. So the very first dot I put on my graph is at -1. Now, after -1, I have to use the slope. Where is the slope in this equation? Well, the slope is 2. But I'm going to put that over 1. If you don't have a fraction, guys, for slope, and just like the one below it, I'm going to go ahead and make it a fraction. 2 divided by 1 is still 2. I did not change the value, but the reason we need to do this is because we have to use rise over run. I'm sure you've heard of that in the past, right? So let's go to our y-intercept again. I'm going to erase this just because I'm going to stick with red just for this equation. I'll put a box in red. So that's our red equation. So I need to go with the slope of 2 over 1. So my rise is 2. 1, 2. My run is 1, and it's a positive 1. So I'm going to go 1 to the right. And I'm going to look at my 2 dots. Always take a quick second after you put the second dot. Is this the way it should be? Is this uphill? It is uphill. If you're going this way, it's uphill. And it should be because the slope is positive. So uphill slopes are positive. That makes a lot of sense. I also like to go in the reverse direction. I went up 2, right 1. I like to go down 2 and left 1 as well. And if you notice, it's on the same line. So I'm going to keep making dots here because this has to be very accurate. So I'll say that again. When you're doing systems by graphing, guys, you got to be extremely precise. Like you have to use a ruler when you graph. You have to be really precise about it. Because the answer is where they meet. So we need to have a good picture of it. All right, I'm going to use the blue one now. So now I can put it over 1. I've got y equals 3x plus 1. So remember, we start with the y-intercept, which is plus 1. Now my slope is 3 over 1. That's my rise of 3. So I'm going to go up 3. 1, 2, 3 blocks. And my run is 1. So I go to the right 1. I'm also going to go, like I said, reverse direction. Instead of up and right, I'm going to go down and left. 1, 2, 3 down and 1 to the left. And it looks like these lines are about to cross. 1, 2. I'm going to keep going. And there it is right there. You see how I put that dot twice there? I could go ahead and try to put lines through these, but since I don't have a ruler here, it'd be a little tough on this big board I'm working on. So I can clearly see that these 2 lines meet right here. So red and blue, I think that makes purple. I hope I'm right. So I'll put a big purple dot right there. I'm going to go ahead and try to finish my lines freehand here, but if they're not perfect, do my best. There's my red line. Please use a straight edge or a ruler for your own lines. And my blue line would look, and that's pretty good, for freehand. But the key is that you understand that the answer to this question is right there. Now, we have to write the answer somewhere. That's how we find it. The answer is where? Where is that place at? So my point there would be -2, comma, -5. Okay, so and honestly, that is my answer, -2, -5. Now I'm going to show you something which is very important, and that's the check. I can't check every one of these. It's just too time consuming for the video, but the first time, we definitely want to know how to check this. How would I check my work? And I'm going to say this again. This is very important, so please listen up. This is an X, and this is a Y, right? That's how we do ordered pairs. Now, inside of each equation, you have an X and a Y as well. Kind of use your thinking cap here. Plug in if that's what you're thinking. So I'm going to go into my red equation here. I've got Y, but I'm going to replace the Y with -5. -5 equals 2, and I have an X here, but I'm going to replace it with -2. And -1, I can't forget. So here's the question. Is this side equal -5? And yes, it does. I just did it in my head. -4 minus 1 is -5. So -5 equals -5. Check. It checks out. The red one checks out. Let's do the blue one now. Plug in -5 for y. So 3 for my x, -2. This time it's +1. So let's take a look. 3 times -2 is -6. -6 plus 1 is -5. And I'm going to squeeze it down here, but -5 equals -5. It checks. So guys, I got to be honest with you. If it checks both of them, you now can circle your answer. You know it's right, 100%. So I kind of want to go through this process again. A lot going on here. A system is 2 lines or more, technically. You can have more than 2, but for this class, we simply do 2. You got 2 lines, and you're trying to figure out where they meet. So you graph them. That's what we did here. And once you figure out where they meet, you simply plug these values into here, which I did right in this area, this check area. And if you get a true, which I got, -5 equals -5, -5 equals -5, I have to be right. And that is the system in a nutshell. All right, some more to practice here. I'm going to speed things up a bit. Well, there's a problem with this one. I like to just start graphing right now, but they're in a form which is a little tough to graph. So there's 2 ways you can do it. You can do it the intercept way, but I'll be honest, what's going to happen if you do the intercept way, which we have done, you're going to get a fraction for one of the intercepts here, and you won't know where to put that. So the best thing you can do in this situation is put it into slope-intercept form. So this time I'll do blue on the top. I'm going to rewrite my question down here so I have room to work. Oops, sorry. Again. Okay, so 3x minus y equals 2. We need to get y by itself. So I'm going to rearrange this equation to make it graphable, what we're used to graphing at least. So this 3x has got to go. Minus 3x, minus 3x. Goodbye. Negative y drops. Don't forget that sign. A lot of people forget that. That's stuck to the y for now. And you cannot put these together. So don't try to subtract 2 minus 3x. They don't go together. They're not like terms. Also, you want to write the 3x term first. So negative 3x plus 2. So at least a little mark there. Okay. It's almost done. I want y equals, not negative y equals. So how do I get rid of this negative sign? Well, if you know what's going on here, it's secretly a -1. So I'm going to divide by -1 and y equals 3x minus 2. That's a lot of work, guys. I mean, you have to change the form sometimes. So this is very graphable now. I'm going to go ahead and graph it since I'm kind of working with it. So I'll put a blue box around this one. -2 is where I begin. And my slope is 3, and that means it's 3 over 1. So very similar to last one. Up 3, right 1. Up 3, right 1. Up 3, right 1. Or down 3, left 1. Down 3, left 1. Okay, got my blue line. Now let's get the red line. Okay, that is not in a good form. So I'm going to have to change the form again. I'm going to go ahead and try and think of where I have room to do this. I'm going to have to go down. So 12x minus 4y. Try to be a little better about my spacing here. We got to get rid of the 12x. So look, same thing I did here. I got rid of the 3x. You do the same steps. So if you're watching this, guys, and you're having trouble with this, just follow the same way I did. You get rid of the x term first. That's completely gone. Negative sign sticks with the 4, so negative 4y equals, remember, write this one first. Negative 12x plus 8, and we're almost there. Now we got to get rid of that -4. Divide by -4. So that becomes a 1, or a 1y, which is what we want. Y equals 3x minus 2. Wait a minute. And this is where I was telling you before, you don't always know they're the same equation. So look at these two. You might look at them and they don't look the same, but they were secretly the exact same equation. Look, 3x minus 2, 3x. So I can just go ahead and, same exact spots. So what does this mean? Remember the beginning of the lesson. There is this situation right here where a line is on top. It's the same line essentially. So what happens when it's the same line? Your answer is they're always meeting. So your answer is infinite solutions. Infinite number of solutions, I really should say. I'm infinite. I'll have to write over my graph here. Infinite number of solutions. So that just means it's the same line. So let's just talk about what are solutions then to this thing. Well, the solutions, guys, are the points. All of these points are on both of the lines. So these are all solutions. So 0, -2, you can plug in and it'll work. 1, 1, you can plug in. 2, 4, 3, 7. Those are all things you can plug in, and you'll plug into both of them and you'll get a true statement. True, true. All right, let's do another one here. I'm going to do this one pretty quick. The reason I'm doing this one quick, they're already in the right form. So let's go ahead and make this the red one this time. -2. My slope is 3. So we've been doing that a bunch. Up 3, right 1. Up 3, right 1. Down 3, left 1. Down 3, left 1. And then I'm going to go right to my blue one. As you notice, I'm going quick here because I can already see I have a little bit of a tip here why this thing, a little secret about it. Let's see if you're picking up on it. I start at +5, right, my y-intercept. Up 3, right 1. Down 3, left 1. Are these lines going to ever meet, guys? What do you think? They're going to meet? They look like they're just staying the same distance apart because they are. What kind of lines are these? If you said parallel, you'd be correct. And I got to say it right here. Look right here. That's a dead giveaway. 3 and 3, they're the same slope. Therefore, the lines are parallel. So what's the answer to the system? If the answer is where the lines meet and the lines never meet, there is no solution. All right, that is literally your answer. The answer is there is no answer. There's no place, there's no point that's on both of these lines. All right, and I'm going to go ahead and end the notes there for today, but I just want to do a quick recap. I hope you're still listening to me. I'm hoping this makes sense. I tried to really break it down. You can have one answer. That's when you have two lines that cross. You can have no answers. We just did one of those. You can have infinite amount of answers. That's when you have the same line, but they disguise it. And as I go through, the one answer here, they're both in slope intercept. That's pretty easy to find. You just simply graph the two lines. If you notice the slopes are the same, you should notice that they're parallel right away. There will be no solutions. That was the last problem we did. And then sometimes they don't look the same. And it's hard to see this, but they don't look the same, but the lines are secretly the same. These are actually the same equation. So you have to rearrange these sometimes to graph them, right? So when you rearrange them and then you realize, oh, they were actually the same line, then you realize it's infinite. And the very last thing I want to leave with, one of the most important parts, is this check. When you found the place that the lines meet, you plug it in to both equations. And if you get true, true, you know you got the right answer. This requires tons of practice here. So don't be discouraged if it's a lot in the same lesson. I'll try to break it down slowly for our example problems.